Hello, this is Mrs. Often, and I'm here with another math video. This one's on proving triangles congruent, and we'll be using SSS, SAS, ASA, AAS, and HL theorems to prove two triangles congruent. I hope this is helpful for anyone who's working on triangle congruence proofs. So again, we have 5 ways of proving two triangles congruent. Please notice that SSA is not one of these, except in the special case of HL congruence. So our first example, we're given that ray QP bisects angle RQS. We're given that QR and QS are congruent, and we need to prove that RQP is congruent to SQP. So before I get started with this, I'm going to say to myself, what can I mark up? Because I know, and kind of make a plan for myself to prove that these two triangles are congruent. Well, I know that there's an angle bisector. So that's going to split this angle into two congruent angles. Looks like I'm one side away from SAS. Do I have that here? And yes, I do, because I have a shared side here at QP. So I'm going to be headed for an SAS congruency, and that's going to help me get started with this. So let's go ahead. We're going to start off with our given statements and our next given statement. Then we have that RQP is congruent to SQP, and that's the definition of bisector. QP is congruent to QP by the reflexive property of congruence. And then RQP is congruent to SQP, and that is by SAS at steps 1, 3, and 4. So pretty quick one there. Okay, in my second example, I have PN bisecting MO. PN is perpendicular also to MO, and I need to prove that MNP is congruent to ONP. So again, I'm just going to put some little markings here with this perpendicular. I know that I have right angles. If I can show right angles are congruent, okay, I've got a pair of congruent angles. Looks like I have a shared side on these two triangles, so I'll probably be using the reflexive property. And this angle bisector is going to give me two angles here, so I think I'm going to be going for ASA, and let's see what happens. So I start with my angle bisector. That's a given. N is the midpoint of MO. So I have a given statement. MN is congruent to ON. So that's the definition of midpoint. PN is congruent to PN. That is the reflexive property. For some reason, nothing is showing up here on my other side of the screen. So I have given, just as a quick reminder here, I've given definition of bisector. I have definition of midpoint. And I have reflexive. Okay, so just looking at what's happening here. So far I've got this, So right now I'm almost to SAS. I'm going to note that PN is perpendicular to MO. That's a given. That's statement 4. My next statement that tells me that angle PNO and angle MNP are right angles. And that's my definition of perpendicular. And since they are both right angles, they must both be congruent to each other. So that tells me PNO is congruent to MNP. that's my right angles congruence theorem. And so now I see I have SAS going on here, so I can say that triangle MNP is congruent to triangle ONP. And as I stated before, that is by SAS. And that came through at 2, 3, and 6. So if you want to note the steps where you figured that out, that's always helpful, 2, 3, and 6. So we've shown that MNP is congruent to ONP. Okay, in example 3, we're going to use AAS to prove these triangles congruent. Gave us a little hint there. It is AAS proving the triangles congruent. So let's see this on the next page. We start off, we're given that X is congruent to V, Y, Z, W is congruent to Y, W. Okay, so again, X is congruent to V, our outer angles here. Y, Z, W is congruent to Y, W, Y, W, Z. And X, Y is congruent to V, Y. So we've got a lot of congruence going on right away. So YZW and YZX are supplementary. And we can see that here. They make up a linear pair. So that's our linear pair theorem. They add up to 180 degrees. Also, YWZ and YWV are supplementary. So keep in mind that these angles, YWZ and YZW, are supplementary to congruent angles. So that means that YZX and YWV must be congruent to each other. That is the congruent supplements theorem. So right now, I have that the two outermost angles are congruent, the two outermost sides are congruent, and I have that YZX and YWV are congruent. That is angle side congruence right there for my two outside triangles, YZX and YWV. So I can say that XYZ is congruent to VYW. And notice that these are named in a way that matches up their corresponding angles. That is by angle side. Okay. Another example. Just going to plot myself a plan for proof here. JL bisects KLM. Okay, so I'm bisecting this angle. K is congruent to M. That's already marked. I have two angles. Oh, I have the shared side. This is probably going to be another angle side. It's going to let me prove that JKL is congruent to JML. All right, that's what I want to do. Let's get started with this proof. So JL bisects KLM. That's given. KLJ is congruent to MLJ. That's going to be my definition of angle bisector. I have another given coming up here. K is congruent to M. Angle K is congruent to angle M. Okay, so there's my angle. And now I'm going to have JL is congruent to JL. Normally this would have a little segment hat on it. My segment hats got lost in my file editing, so I am sorry. That's the reflexive property. Okay, I have my angle, and I have my non-included side here. So when I say JKL is congruent to JML, that is going to be by angle side on steps 2, 3, and 4. Okay, my figure is upside down here, but I'm given that CB is perpendicular to AB. CB is also perpendicular to CD, and I have congruent segments at AC and BD. I want to prove these two triangles congruent here. That would be ACB and DBC. So here's all of my givens given to us at once. Okay, I do have two right angles, and that's my definition of perpendicular. Now, because they're both right angles, I can use my right angle congruence theorem to state that ABC and BCD are congruent angles. BC is congruent to BC. That is the reflexive property. And then I'm going to end up with this segment here. That's a leg. And I have the hypotenuse of the right triangle. So I can say that ABC is congruent to DBC by the hypotenuse leg theorem. And that's at steps 1, 3, and 4. Okay, my final example here, I have FASIG along this line. I have angle FAB outside the triangle is congruent to angle GED. I have angle ACB and DCE are congruent to each other. And I have these two sides, corresponding sides for the triangles here. I need to prove that ABC is congruent to EDC. So just a couple of little markings here to kind of get myself started. Okay, so I have AC and EC. I have these exterior angles. And then I have these two angles right here. So I notice I'm like one away from having angle side angle. If I could get this angle here, this angle here. Now before in another proof I had used congruent supplements, so I think I'm going to be using that again. So let's look at this proof and see where it goes. Okay, so here's just a duplicate. I'm going to start with some of the stuff I'm given. FAB is congruent to angle GED. Those are my outer angles here. Now, BAC is supplementary to FAB, and DEC is a supplement of GED. That's my linear pair theorem. So BAC is congruent to DEC because of congruent supplements. These two angles are congruent to each other because they are supplementary to two congruent angles. Okay, so this is good. I have two angles, and as long as I have any side, whether it's included or not. So ACB is congruent to DCE and AC is congruent to EC. That was already given to me. So let's see what I have marked right now. I have BAC and DEC. I have ACB and ECD, and I have those two sides. So that's going to be angle side angle. And there we are. That's angle side angle through steps 3 and 4. And again, that just helps when you note those steps to see where it's coming from. So I hope this was helpful to you in getting some more proofs of congruent triangles. Have a great one.